In this example, I want to figure out the energy generated by this triangular solar panel. And what I'm told is that every square foot of the panel generates approximately 200 watts of electricity per hour. I don't know whether that's true or not, or if that makes sense, but we're going to go with it in this case. And so I know all three sides of my triangle. I know that I have a 30-foot side, a 30-foot side, and then a 50-foot side. And so what I'll need to do is find the area of this triangle. And using some formulas we've discussed in class, when I know all three sides of the triangle, one of the easier formulas to use is Heron's formula, this is Heron's formula. I wanted to have that pop up real quick. So S, remember, is the semi-perimeter, half of the perimeter, and then A, B, and C are the different side lengths. So my first step is going to be to find the semi-perimeter of this triangle. The semi-perimeter is simply half of the perimeter, so half of the three sides added together, 30, 30, and 50. And I find out that the semi-perimeter is 55 feet. Okay, so I can go ahead then and plug all this information into my formula to find out its area. So the area is equal to the square root of the semi-perimeter, 55. And then three sets of parentheses where I subtract the different side lengths from that semi-perimeter. So 55 minus 30, 55 minus another 30, and then finally 55 minus the third side, which was 50. Okay, so using a calculator for this, I'd recommend you do it at least in a couple steps and try not to type this whole thing at once. I come up with the square root of, checking my notes, 171,875. You can go ahead and pause the video and double check that on your own. Each of those four parts multiplied together. And then finally taking the square root of that, I get an area for my triangular solar panel of approximately 414.58 square feet. Well, that's not the answer to this question because they weren't asking for the area of the roof. They were asking for how much electricity is generated. Well, since I now know the area, and I know that every square foot generates about 200 watts of electricity, I'm going to take my area and multiply that by 200, because for every foot squared I get 200 units of electricity, watts of electricity. And so multiplying those values together, the area times that rate, I come up with 82,916 watts of electricity per hour. And again, I don't know if those are the right units or whatever, but we're just going to go with it and say that that's going to make sense. If it doesn't make sense, I apologize. Hopefully the math, or I know the math will check out. Whether the units check out, I don't know. Don't really care about that right now. I know that my math checks out.